Okay, so now we're actually ready to classify the data. And so I've removed the other two layers because we don't need those, just working with the clipped subdivision layer. So what we want to do is first open the attribute table. And so again, we see we've got population, income, food, along with shape length and shape area. When you downloaded the shapefile, it didn't come with any shape area associated with it. But when you put a layer into a geodatabase, the shape area is automatically calculated. And since it's projected in the desired projection, we can be confident it's doing what we want. So the first step is to add some fields. The method for calculating population or for classifying rural versus urban relies on total population, which we have, but also population density, which we don't have. So you should already know how to do that because we did it in Module 2. So I'm not going to show you how to do that. This video is going to pick up, assuming that you've already done that. But I will leave you with one tip. When you go and calculate population density, remember that the units that the projection is in is meters. So all these shape areas are in square meters, but the classification method defines the rural or the urban rural versus urban using population density in square kilometers. So remember, we need to get the population density in square kilometers, not square meters. Those are vastly different numbers that differ by an order, multiple orders of magnitude. So I'm going to pause this, calculate population density, and then restart in a moment. All right, so I've calculated population density. I've sorted it in descending order. So you can see Vancouver is the most densely populated census subdivision in the province. Nearly 6,000 people per square kilometer, population of nearly 700,000. Interestingly, somewhere with a population of 20 has the next highest population density. So again, vastly different populations, but also look at these different shape areas, right? So if you zoom to this layer, it's just a little block. You zoom to this layer, it's a whole city. Just an interesting note, right? So this highlights what data normalization can do. Anyway, just a note, anytime you got stuff selected, it's always important to remember to clear that because if you don't, it can cause issues down the line. So now we want to create our classification scheme. So we add a field again. And you notice I've called population density, pop density. You can call it whatever you want. This is going to be the urban rural classification. So I'm going to call it urban rural. It's very important to make sure that this one is of data type text because we're just going to use letters, text characters to fill this one in. So we're not going to use any numbers. This is going to be a nominal categorization. So make sure you save it, and then you can just close this. Scroll over, we've got the urban rural one, and it's empty. So now what we need to do is populate it. So this is pretty easy to do. All we're going to do is click select by attribute. You can either find it up here or down here in the table. So we'll just do it in the table. Click select by attribute. It automatically knows this is the one we're working with. Leave it at new selection. And then we'll just create an expression. So Statistics Canada has two categories for the old classification method to differentiate between an urban and rural area. So let's define urban. That is any region with a population density that is at least, so greater than or equal to 400. And we'll need to add a clause here. We're going to say and it needs to have a population of at least 1,000, meaning is greater than or equal to 1,000. We click apply, and you'll see that it selects 64 out of the 737 entities. So if we now have just these selected, we can right-click and say calculate field. And all you have to do now is just type in, with quotation marks, the text that you want to use. So I'm just going to use the letter U to define this as urban. You can type out the full word if you want. It won't matter. Just make sure that you understand what you're doing. You click OK, and you see that it populates just the ones that we've selected. Now, there's a quick, easy way if you're doing just either or type things where you can just switch. If you click this button, it switches and selects everything that's not already selected. But I'm going to clear this because I want to highlight a point. So what this select by attribute does is it uses something called structured query language, or SQL, to define a query. So you're selecting for all the records where certain conditions are true. In this case, we have two conditions to meet. So the definition for urban is population density at least 400 and population at least 1,000. The definition of rural is the opposite of that. So population density less than 400, or population less than 1,000. You click OK or apply, either one, and you get the same result you would have had you switched, right? So that highlights a bit about structured query language. It's a useful tool for querying your data set, hence the name. So now you can right click and you can say calculate field, and then you just type quote in quotes the letter R. Click OK, and you've generated the classification scheme. Clear your selection, and just to visualize what this looks like, the implications that this has, go to symbology. And then you can click unique values, select urban rural. Whenever I do this, it always brings up this all other values. Whenever I do this, I like to just click on it. And unless I really need to show values that aren't classified, I just delete it. So it doesn't even pop up on the legend. All you have to do is hit the delete key. So you'll notice nearly all the province is rural. You can zoom in. You can see that there are urban areas in the Metro Vancouver, Victoria, and Nanaimo areas, and other small ones scattered throughout the province. But most of the area is rural.